Hi friends, welcome to Edumento. In this video, we will be going through the functionalities or the different characteristics of operating system. So what's an operating system? Operating system is an interface or it's a communication bridge between the users and the computer hardware. And the main purpose of an operating system is to provide a platform on which a user can execute the programs in a convenient and efficient manner. So in my previous video, I have explained in detail about what's an operating system and what all are the primary goals of an operating system. So if you haven't seen that video, please go through that video because in that video I have explained everything in detail with real life examples. So please go and watch that video and come back to you. Okay. So let's get started with the functionalities of operating system. So the first functionality of operating system is resource manager. The operating system acts as a resource manager. So what do you mean by a resource manager? Or what all are the resources we have? The resources includes our CPU, or we can call it as the processor. Then we have the RAM, or that is our primary memory, or we can call it as the main memory. Then we have various I/O devices, that is the input-output devices. So these all are some of the resources of a computer hardware. Now how can we manage these resources? In case of a single user interface, there is no issue. There will be one user, he is having one system or one computer or one desktop, and that system and all its resources is dedicated for that single user. So he can access all the resources he needed. But what about in a case of a multi-user environment? In case of a multi-user environment, there will be multiple users. So many users will be there and some of the hardwares will be shared among these users. So these resources or these hardwares should be shared in an efficient manner to each user so that each of the users get a fair amount of all the resources. So it's a functionality of the operating system to manage the resources. For example, when you open the task manager, how can you open the task manager? The shortcut is to press the Alt button, Control button and Delete button. You have to press all these three buttons together, Alt plus Control plus Delete. Then you can open your task manager. In the task manager, you can see the utilization, the percentage of utilization of CPU, your memory, disk, as well as your network and so on. So you can go through it by checking your task manager. Also in the task manager, you can see which all applications are open right now. In your system, if you are typing some documents, your Word document will be, MS Word will be open, and at the same time you are hearing some music. So your music player will be open. So in that case, if you open your task manager, you can see that in opened applications, MS Word will be there as well as your music player will be there. Apart from this opened application, there will be some background processes running in your system. For example, your antivirus. The antivirus will be running in the background whenever your system is turned on. These background processes are also using your resources. So it's a function of the operating system to allocate as well as to deallocate the resources among different processes. And among this resource manager, for each these resources, for the processor or for the CPU, as well as for the main memory, and also for the I/O devices, we have to manage them separately. So when we talk about the I/O devices, there comes our second functionality, that is device manager. So the operating system acts as a device manager. That means the operating system should take care of the I/O devices. Let's take one example. There is an office and in that office room so many computers are there. Suppose that there is 3 computers. That means 3 users are there and all these 3 users are sharing one printer. This is our printer. So we can say that there is one printer shared among 3 different users. And let's suppose that all these 3 users want to take a printout at the same time. But we know that at a time only one of these users can take the printout. So to which user this printer must be allocated? It can be allocated to any one of these three users, but to which user the printer should be allocated or for how long the printer should be allocated. All these details are managed by the operating system. Thus, the operating system acts as a device manager. Then comes our next functionality, that is process manager. So the next functionality of operating system is it acts as a process manager. This comes in picture when we have a multi-programming environment. In a multi-programming environment, the operating system should decide the order in which each processor gets a CPU or the order in which the CPU is allocated to each process. That ordering is done by some algorithms, and that's our process scheduling algorithms. And they are also known as CPU scheduling algorithms. So it's a functionality of the operating system to decide to which process the CPU must be allocated, as well as after how long time, after how much time the CPU must be deallocated from that process. So both the allocation and deallocation of the processor. Processor here means our CPU. So this is also the functionality of operating system so that each process gets a fair amount of CPU. Now comes our fourth functionality, that is memory management. Here when we talked about memory management, we are considering the main memory. The main memory is also known as the primary memory, and that means our RAM. RAM means random access memory. So in case of memory management, we will be considering the main memory or the RAM. So whenever we talk the term memory, it refers to RAM. It refers to the RAM only. Okay. So we know that in order to run a process, that process must be residing in the main memory. That means the CPU can read the instructions only from the main memory. So whatever process we have to run, we should take it inside the main memory. So in the main memory, there will be so many processes. Which all programs need to be executed, those programs will be taken inside the main memory. And due to that comes the concept of multi-programming. And this multi-programming, we will be discussing it in detail in the upcoming videos. So for now, let's consider that there is a main memory and inside that main memory, there are some processes. Let's suppose that there are 5 processes that need to be executed. But these 5 processes cannot run at the same time. Only one of these 5 processes who gets the CPU can run at a time. So these processes will be residing in a queue inside the main memory. And they will wait there in order to get their turn of CPU. So in such a case, the operating system will be deciding on how much memory a process should get, how much memory should be allocated to a process, and how can we take that memory back. That means the allocation and deallocation of the main memory is the function of operating system. So right now we said that the CPU can load the instructions from main memory only. So whichever programs we have to run, whichever process we have to do, they must be residing in the main memory. Thus, ideally, we want our entire programs and entire data to be residing inside the main memory. But that's not practical. We cannot do so. Why? Because of the constraints of main memory. So, the two constraints of main memory, they are, first one is the limitation of size. That means the main memory is too small, so that we cannot save or we cannot store all the programs and data inside the main memory. We cannot store them permanently in the main memory because the size of main memory is too small. And the second constraint is that the main memory is volatile. Volatile means it will lose its contents or it will lose its data when the power supply is turned off or when there occurs a power failure. All the data inside the main memory will be erased. So we cannot store the data permanently inside the main memory. So due to these two limitations, we need another memory and that's our secondary memory. So in that case, the operating system should take care of the secondary memory also. And that's the fifth functionality of operating system, that is storage management. So in case of storage management, we are talking about the secondary memory And in case of memory management, we are talking about the primary memory. So here we are talking about the secondary memory or the hard disk. And the secondary memory is non-volatile, so that we can store our data and programs permanently inside the secondary memory. And also the size of the secondary memory will be large, so we can store any amount of data inside it. And how does this operating system take care of secondary memory? So the operating system makes use of the file systems in order to access the secondary device. That means in order to save a file or in order to open a file, read a file, for everything the operating system make use of the file systems. And using these file systems, the operating system can decide in which disk or in which sector or track of disk the data is stored. We will be learning about the disk structures in detail later. Now just know that the disk is divided into different tracks and sectors, and the data will be saved inside these sectors or tracks. Also, these files will be saved inside a directory, and each directory will be subdivided into subdirectories. That means we can save our files inside a folder, and inside one folder we can create another folder, and so on. So these are all done by the file systems, and this is a functionality of operating system to manage the secondary memory. And the last functionality of operating system is security, or we can call it as the privacy or protection. For example, when we switch on the computer or when we turn on our laptops, first what will be asking, the Windows will be asking for the password. If you have set a password, the Windows will be asking for the password. So that's a kind of security. Why they are asking for the password? It seeks a password in order to authenticate the user, to confirm that the correct person is using the computer. And if you type the password incorrectly, or if some wrong person is using the computer and they type a wrong password, then the Windows can block that user. That means the Windows will block the user from entering inside your computer. So that's a form of security provided by operating system. Apart from this, the operating system provides security inside the RAM also. That means inside the main memory also, the operating system provides security. For example, suppose that this is our main memory. That means this is our RAM. And there are some processes inside this main memory. Suppose the process P0 is residing from 0 to 100, and there is another process P3 that takes the place from 101 to 200, and there is another process P7 that takes the place from 201 to 300. Just assume that these are the memory locations provided for each of this process. So it's a responsibility of the operating system to ensure that none of these processes should interfere with each other. That means this process P3, this process should not read any instructions of the process P0, or the process P3 should not read any instructions of the process P7, as well as the P3 should not interchange any data with the process P0 and P7. So it's a duty of the operating system to provide security among these processes inside the main memory. So if it finds any process interfering or interchanging data with other process, then that process should be blocked. So these all are the different functionalities of operating system, and we will be learning each of these functionalities in depth in the coming videos. For example, this process management itself is a complete unit, and the storage management. Here the disk structures, everything, and the file systems, they are all different chapters. So you will be learning each of them in detail in the coming classes. So that's all for today. So in this video, we learned about the different functionalities of operating system, and in the upcoming videos, we'll be learning about the different types of operating system. So see you in the next session. Thank you.